James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
The latest finding made by the James Webb Space Telescope, the most sophisticated telescope ever built, has once again taken the world by surprise. This time, the public's interest has been piqued by a considerably more intriguing and perhaps unsettling discovery. Rather than far-off nebulae or the birth of new stars, the exoplanet Proxima Centauri b, which orbits Proxima Centauri, our nearest stellar neighbor, features lights that resemble cities as seen by the telescope. If this finding turns out to be artificial illumination, it has the potential to completely change our concept of life as we know it and challenge many long-held beliefs about where we fit into the universe. Such a discovery has enormous ramifications that go far beyond astronomy, extending into the fields of philosophy, technology, and even geopolitics. Please click the like and subscribe icons before we begin for more exclusive news. An exoplanet called Proxima Centauri b, or simply Proxima b, is situated 4.24 light-years away from Earth. This rocky planet is located in its parent star's habitable zone, which means that liquid water might potentially exist on its surface. Because Proxima resembles Earth, scientists have conjectured that it may be home to life ever since it was discovered in 2016. However, the question remained mainly hypothetical. But the latest findings by James Webb have given this idea a concrete, if unusual, new perspective. With its advanced infrared detection capabilities, the James Webb Telescope was able to take pictures of what appears to be a regular pattern of illumination on Proxima b's dark side. The lights don't seem to be randomly arranged; instead, they appear to form a structured grid pattern reminiscent of Earth's city lights as seen from space. Concerns over the nature of the light source were immediately raised by this discovery. Is it a product of nature, or is it proof of man-made technology? If it is artificial, that would indicate the existence of a highly developed society capable of creating and maintaining intricate infrastructure, possibly even on par with our own. It's both exciting and unnerving to consider the idea that these lights are artificial. There appears to be some organization and purpose behind the lights, as their structured quality is not usually connected to natural atmospheric or geological phenomena. The grid-like pattern and enduring illumination that James Webb observed could not be explained by any of the natural phenomena that have been proposed, including volcanic activity, lightning storms, or bioluminescence. For instance, volcanic explosions could not maintain the same intensity over time and would result in erratic light patterns. Bioluminescence on a planetary scale is an intriguing concept, but given our current understanding of biology, it would require an extraordinary abundance of life forms emitting light simultaneously in a structured way, an unlikely scenario. Additionally, lightning is typically brief and sporadic. Consequently, the most plausible explanation that remains is that these lights are artificial, potentially coming from a civilization that has harnessed energy in a manner similar to how human technology has advanced. The finding on Proxima b would be the first in history where possible evidence of an extraterrestrial civilization has been detected by humans. Provided it is verified as city lights, this would imply that highly technological cultures are not as rare as some theories suggest, and it would show that we are not alone in the cosmos. It would refute the Fermi paradox, which asks why, given the abundance of planets that may harbor life, we have not yet detected any indications of extraterrestrial intelligence. The apparent discovery of artificial lights on Proxima b may indicate that sentient civilizations abound throughout the galaxy. The reason we haven't detected them until now might be due to limitations in our observational techniques rather than a genuine scarcity of alien societies. There are significant ramifications for astrobiology. Up until now, scientists have mostly concentrated on searching for microscopic or rudimentary forms of alien life, assuming that the chances of discovering advanced civilizations are low. The apparent brightness of Proxima b could prompt a reconsideration of that position, implying that the planet residing next to us in the universe might be inhabited by intelligent, life-forming entities. This raises the question of how many other neighboring stars may host planets exhibiting comparable indications of intelligence. This finding may lead to a more focused search for technosignatures or evidence of technology developed by alien intelligences on additional nearby exoplanets. This breakthrough could significantly alter our perception of technological and societal progress, being both encouraging and concerning if an extraterrestrial culture has attained a level of technical proficiency comparable to or possibly surpassing our own. The possibility that another culture may independently create artificial lighting and planetary-scale infrastructure raises the possibility that the evolutionary route leading to modern civilization is not as singular as we previously believed. Significant ramifications would also follow for the so-called Great Filter hypothesis, which postulates that civilizations may either self-destruct or face impassable obstacles before reaching interstellar status. A civilization on Proxima may have escaped the traps that may cause society to collapse, suggesting that existential dangers like these are not always unavoidable. The possible finding of artificial lights on Proxima b may raise significant philosophical and cultural issues in addition to scientific ones. Existential discussions concerning our role in the universe and whether or not we are alone have dominated human history. A definite response to one of humanity's oldest issues would come from the confirmation of an intelligent extraterrestrial culture, and it would also lead to a reevaluation of our own cultural narratives and religious beliefs. The finding may help foster a greater understanding of our common humanity by highlighting the fact that, in a world abundant with life, we are all only occupants of one little planet. The identification of these lights may also significantly alter the goals and areas of concentration for space exploration initiatives. If there's even a remote possibility that these lights are man-made, it would be hard to argue against investing additional funds in further investigating Proxima b and its surroundings. The development of new technology for interstellar travel or the sending of probes that can reach Proxima Centauri within a human lifetime might be prioritized. Increased interest in initiatives like Breakthrough Starshot, which aims to deploy tiny light-propelled probes to the Alpha Centauri system, may also result from this revelation. Indeed, the importance of a direct exploration trip may potentially eclipse that of Mars settlement as the next big challenge for human space endeavors. From a technological point of view, seeing lights on Proxima b may also assist focus efforts on finding certain technologies that the postulated civilization may employ. Researchers might start looking for electromagnetic radiation, such as radio waves or laser transmission, that could come from a culture with advanced technology. The finding may potentially have an impact on telescope designs in the future, leading to the creation of tools meant to look for indications of human habitation or energy use on far-off planets. But the finding also begs concerns about the dangers of communicating with a civilization that may be highly developed. Some scientists and intellectuals have been warning us for decades not to publicly announce our presence to the cosmos out of concern that we would not benefit from a meeting with a better developed civilization. It's possible that the lights on Proxima b already know we're here if they come from an advanced society. It's unnerving to think that only a few light years away, aliens may be observing us. It may lead us to become more circumspect in our quest for alien intelligence, preferring to observe from a distance rather than announce our existence to the universe. There are even more possible consequences that relate to moral and practical issues. The discovery of intelligent life on Proxima b may compel national and international organizations to set up procedures for communicating with alien societies. These guidelines would have to cover the ethical issues of cultural intrusion and contamination in addition to the scientific and diplomatic elements of making contact. In the event that Proxima b is inhabited, we must think about how our actions would affect their culture and if it is morally or practically appropriate to make direct contact. With the goal of comprehending the biological and cultural facets of extraterrestrial life, the expanding science of xenobiology may find itself at the center of these debates. Furthermore, the finding may pique interest in space colonization and the advancement of technology that would make it possible for people to settle on other planets. It may now seem more feasible, or perhaps necessary, than ever to become a multiplanetary species in light of the discovery of a neighboring exoplanet exhibiting evidence of sophisticated life. The need to come up with a backup plan for mankind may grow, especially in light of persistent problems like resource depletion, climate change, and geopolitical unrest on Earth. A plausible theory that an intelligent civilization exists just a few light years from Earth might spur space travel and off-world living practices research. The discovery of man-made lights on Proxima b may also force scientists to re-evaluate their current hypotheses about the formation and evolution of planets. If intelligent life exists on other planets, it might indicate that civilizations on other worlds formed sooner than previously believed or under different conditions than on Earth. The conventional Earth-centric concept of life formation, which holds that sophisticated life forms after a protracted and stable geological past, would be called into question by this revelation. The apparent evidence of civilization on Proxima b suggests that, under the right circumstances, life may emerge quickly even on worlds with hostile or unstable surroundings. Furthermore, the idea of planetary stewardship and sustainability may be significantly impacted by the discovery of a civilization on Proxima b. If this society has persisted for a long time, it suggests that, in spite of their difficult surroundings, they have managed to strike a steady balance between ecological preservation and technological advancement. This might offer insightful information on how humans can handle problems like environmental preservation, sustainable energy, and resource management on Earth. A civilization on Proxima b may provide an example or case study of how sentient entities could achieve long-term planetary sustainability in environments very different from Earth's. Additionally, it is possible that the Proxima b civilization is significantly more developed than our own, with knowledge and technology that might be hundreds or even millennia ahead of us. If the lights on Proxima b are artificial, methods or energy resources currently unknown to science may be employed by their technology to produce this kind of organized illumination across the planet. This creates the exciting possibility that, should contact be made, humanity may eventually learn from this civilization. Knowledge sharing has the potential to spur technical advancements on Earth, resulting in innovations in fields like artificial intelligence, space exploration, energy production, and even medicine. However, there are serious practical and ethical issues associated with this potential. Humanity would need to consider who should have access to such information and how it should be utilized if advanced technology were obtained from an extraterrestrial culture. Sharing technical knowledge across civilizations carries certain hazards, especially if the technology has the potential to be weaponized or used maliciously. In such a scenario, humanity would have to proceed cautiously, ensuring that any information acquired is applied for the good of all and not exploited for personal advantage or financial gain by a select few. Discussions concerning intellectual property, governance, and the rights of alien beings would inevitably arise from these circumstances. The possibility of an extraterrestrial civilization also has cultural implications. A major cultural upheaval on Earth might result from discovering city-like lights on Proxima b and the subsequent confirmation of intelligent life. Themes related to alien life and our growing understanding of another society could permeate human art, literature, music, and even language. This cultural shift might unify humanity through a shared sense of belonging to a greater cosmic community, inspiring new ways of thinking and living. Such inspiration could lead to a cultural renaissance fueled by discoveries and the curiosity they evoke. On the other hand, cultural influences might cause conflicts and divisions, especially if different groups have varying opinions about how to engage with the alien society. While some may advocate for caution and isolation, others might support rapid communication and collaboration. Social unrest could arise from the emergence of new philosophical or religious movements based on the possibility of alien life. Questions about how the religious and cultural practices of the Proxima b civilization might interact with human beliefs would surface, potentially leading to challenging moral dilemmas concerning the preservation and exchange of cultural traditions. Beyond intellectual and cultural debates, the discovery of artificial lights on Proxima b could have practical ramifications for space policy and international relations. The prospect of encountering an extraterrestrial society might encourage nations to collaborate more closely on space research. Organizations such as the United Nations might take on a more prominent role in overseeing space exploration activities, ensuring that no single nation or entity wields excessive influence over decision-making regarding alien life. Countries could pool their resources and knowledge to enhance our understanding of the cosmos and humanity's place within it. The discovery might also impact laws governing space travel and alien studies. International space law, still in its infancy, has few established rules for dealing with extraterrestrial life. The presence of lights on Proxima b could accelerate the development of agreements and regulations aimed at protecting alien habitats, establishing communication channels, and addressing legal issues related to extraterrestrial encounters. For instance, sending a probe to Proxima b would raise concerns about contamination in both directions. Efforts would be needed to prevent potentially harmful microorganisms or materials from Earth from contaminating the alien environment, while simultaneously safeguarding any life forms already present. It is possible that a Proxima b civilization is actively seeking contact and that the lights detected by the James Webb Space Telescope were part of a deliberate attempt to signal or communicate with other sentient species. If so, this could suggest that they share humanity's curiosity about the cosmos. The lights might serve as a cosmic lighthouse, designed to attract attention from other planets. This would imply that, like humans, they have not yet achieved long-range communication or interstellar travel. If true, it might suggest that Proxima b's culture and humanity are on similar technological trajectories, raising the possibility of meaningful communication in the near future. Even if the lights are artificial, their nature might reveal much about the civilization's aesthetic and cultural values. For instance, distinct lighting patterns and intensities could represent various functions, such as residential areas, commercial hubs, or historical landmarks. Variations in hue or spectral characteristics might indicate different energy sources or technologies. By analyzing these patterns, scientists might deduce insights about the civilization's energy usage, technological advancement, and social structure. Such findings could inspire new scientific theories about how advanced civilizations interact with their environments. Human activities on Earth leave detectable traces, from artificial light pollution to atmospheric changes caused by industrial activity. Similarly, the discovery of city-like lights on Proxima b could motivate researchers to search for novel types of technosignatures when exploring other planets. This might lead to the development of new observational techniques to detect technological or infrastructural indicators, such as energy beams, artificial satellites, or megastructures like Dyson spheres. If the lights on Proxima b are artificial, their presence may provide insights into the civilization's evolutionary timeline. Scientists could speculate about how long the lights have been in place and whether we are observing the civilization at a specific stage of development. Such observations might help humanity better understand the life cycle of civilizations and whether technologically advanced societies tend to endure or collapse over time. This knowledge could be crucial for humanity's long-term survival, highlighting trends or warning signs linked to societal decline. The discovery of city-like lights on Proxima b could transform our understanding of planetary systems as interconnected networks rather than isolated entities. It might suggest that galactic planetary systems are not as autonomous as once thought. If intelligent life exists relatively close to our solar system, space might host complex interactions among civilizations, including resource exchanges, communication across star systems, or even interstellar travel. This concept of a cosmic web of interdependent communities could redefine our understanding of life in the universe. Scientifically, such a finding could lead to a deeper investigation of stellar environments and their impact on planetary habitability. If Proxima b harbors life, it would challenge theories that red dwarf stars are too volatile to support life, demonstrating that planets orbiting such stars can sustain civilizations. This could trigger a wave of new exoplanetary discoveries as researchers reassess red dwarf star systems, the most common type in the Milky Way. If life can thrive in such environments, it may suggest that advanced civilizations are far more prevalent than previously believed. Moreover, the discovery on Proxima b could revolutionize physics and cosmology. Advanced civilizations might have developed a physics beyond our current understanding, offering solutions to some of the universe's greatest mysteries, such as the nature of dark matter, dark energy, or cosmic expansion. Long-term information exchanges with such a civilization could lead to groundbreaking discoveries, paving the way for revolutionary technologies like new energy sources or advanced spacecraft propulsion. The arrangement of lights on Proxima b might hold symbolic or communicative meaning, reflecting artistic or cultural expressions embedded in their nighttime landscapes. These lights might be designed to convey messages or signals to distant observers, hinting at the civilization's technological capabilities, history, or desire for interaction. Even if the lights are unintentional technosignatures, their discovery could prompt humanity to re-evaluate how civilizations inadvertently reveal their presence. A civilization on Proxima b might unknowingly emit observable signals, much like Earth does through radio waves, infrared emissions, or atmospheric changes. This realization could drive a more vigorous search for similar technosignatures in nearby star systems. If an alien civilization were discovered so close to our solar system, it would likely shift the focus of extraterrestrial research. Decades-long passive SETI efforts to detect radio signals might give way to actively seeking technosignatures across various wavelengths using specialized telescopes and sensors. This approach could better detect inadvertent emissions from advanced societies, such as excess heat from energy use or unusual atmospheric compositions, advancing the search for extraterrestrial life.